everyone, Ms. Kilroy here. Yesterday we left off in the middle of notes, so I just want to make sure we get all of the information into our science notebook. So go ahead and pull that out. I think first period didn't quite finish condensation, but second period did. So second period, you guys can go ahead and fast forward to the next part of the notes. First period, make sure you get all of these notes down. Let me just explain condensation for a little bit here. So condensation, going from a gas to a liquid. This occurs when energy is removed from a gas and it slows down those molecules and turns it into a liquid. So we're removing energy and we're slowing down those fast-moving gas molecules into slower liquid molecules. The condensation point is the same temperature as the boiling point. So it's a temperature at which a gas becomes a liquid. So water boils at 100 degrees Celsius. That's the boiling point. That is going from a liquid to a gas. But if we're going the other way, the condensation point is also the exact same temperature, 100 degrees Celsius, going from a gas to a liquid. It just depends if you're either adding energy or taking away energy. Here's my example of condensation. So if you leave a cold can or a cold bottle out in the sun, condensation occurs on the outside of the bottle. This is because the gas from the outside environment touches the cold can. It slows down those molecules and turns them into a liquid. Okay, so this liquid is not coming from the inside of the can. The can's not leaking, it's not melting. It occurs because of the outside environment gas touches the cold can, it removes energy and turns that gas into a liquid. Sublimation, going from a solid to a gas. Just a heads up, if I'm ever going too fast, feel free to pause the video so the whole class can catch up and get all of the notes down. Sublimation is going from a solid to a gas, so we're just skipping over that liquid state. The particles go from being really tightly packed to not moving very much, just vibrating in place, to having a lot of energy and spread far apart. Okay, so sublimation is where we're adding a lot of energy. So for example, dry ice at room temperature, the molecules in the ice begin to move so fast that they escape the solid and go directly to a gas. So my example is sublimation. So dry ice, you have solid blocks, turn straight to a gas. All right, deposition, going the opposite way, going from a gas to a solid. This is the opposite of sublimation. We're removing energy. And this is basically where water vapor, the gas, turns directly into frost. So on super, super cold days, sometimes in Santa Barbara we have it here. You can see it out on the grass in the PE field. Only happens when it's really, really cold. But the gas from our outside environment goes straight to a solid. So those fast gas molecules, so much energy has been removed that the particles have slowed down and turned into a solid. Okay, the next part right here, I want you to put this on we'll put this on page 68. So this is going on the left-hand side of your science notebook. I want you to copy this exactly. You can turn your notebook sideways to make sure it fits the whole page. And there's going to be some things you need to add in, so you need to listen to me as well. Sorry about that. I just realized that some things are missing. All right, over on our vertical axis, we have temperature in Celsius. On our x-axis, this is the heat added, and our title is phases of water. So basically, as you can see, the diagonal lines are our states. Okay, so here is a solid, liquid, gas. Now here, this horizontal line, this is where the temperature remains constant for a period of time because it's using energy to change state. So right here at this line, I want you to write 0 degrees Celsius. I wonder if I can write that in. Yes, I can. All right, so write in a 0 right here. This isn't very good, but do your best. So at 0 degrees Celsius, solid water, ice, turns into a liquid. So this is our melting point if we're going from the left to the right, right? So here we're adding energy. We're going from a solid to a liquid, and it's melting. If we go the opposite way, if we start as a liquid and remove energy, we are going to a solid. And this is called freezing. So the freezing and melting point, as you can see, it happens at the exact same temperature, 0 degrees Celsius. It just matters if you're adding energy, it's melting, or if you're removing energy, it's freezing. Okay, now let's go to this portion. Here we're going from a liquid to a gas. When we're adding energy, it is called vaporization. So going from a liquid to a gas. If we remove energy, so going from right to left, starting as a gas and going to a liquid, it's condensation. Okay, this happens at, I want you to write this in, 100 degrees Celsius. So at 100 degrees Celsius, if you are adding energy, you're going from a liquid to a gas, it's called vaporization. If you're removing energy, you're going the opposite way, going from a gas to a liquid, it's called condensation. Okay, so again, notice how this horizontal line is flat for a little bit. Same with this one here. So the freezing and melting points, condensation and vaporization points, those are horizontal because all the energy is being used to convert the substance from one state to another. Okay? All right, so make sure you have this copied down, and then go ahead and turn to the next blank page. So after the deposition notes, go ahead and turn to the next blank page on the right-hand side. Actually, wait, just kidding. Okay, I'm doing one take of this, everyone. Let's have our lovely substitute hand out the changes of state homework, and then flip it over. There are C notes on the back of that. Okay, on the back of those C notes, I want you to title it endothermic versus exothermic. And the play button is where? There we go. All right, so label your C notes at the top, endothermic versus exothermic. I'd like the essential question to be, what is the difference between endothermic and exothermic, and how are they similar? So basically compare and contrast endothermic versus exothermic. And the first thing I want you to do, you don't have to write out these questions, but on the C note paper I want you to write one, and I want you to answer this question on your own. So what is similar between the two words above? So look at the prefix and then the end parts and tell me what is similar between them. Number two, on your own, what is the difference between these words? Number three, make a hypothesis. What do you think the word exothermic means? Break the word down into parts. And then number four, what do you think endothermic means? Okay, once you have all of these answers, you're going to need more time than I'm giving you right now. I want you to discuss it with your partner for about 1 minute, and then go ahead and play this video again, and we'll go over the answers. All right, so let's put these notes into your science notebook on the next blank page. So after what I was saying before, after the deposition notes on the right-hand side, the next blank page, title it this, and I want you to write this down. So exothermic is a process in which energy is released. We're removing energy. Energy is exiting. You like my theme there? Exiting. Okay, so for example, glow sticks. If you break open a glow stick, you can feel that it's giving off a heat. So glow sticks, fire, basically anything that feels warm in a chemical reaction that's giving off heat, it's releasing heat, heat is exiting, that is an exothermic process. Endothermic is just the opposite, a process in which energy is absorbed or added. So energy is entering. Energy is entering, energy is exiting. And for endothermic, for example, those ice packs. So when you hurt yourself in PE, you squeeze open the ice packs, the two chemicals mix together, and it becomes really, really cold. So it's removing energy from the outside environment and becoming really, really cold. So when we release energy and it's hot, it's exothermic. When we absorb energy from our outside environment and it feels cold, it's endothermic. Now, not always is it going to feel hot or cold. It has to do with energy exchange, but these are some helpful ways to remember it. All right, and these we will go over later, so I just want you to get those basic notes down, and then once you have these notes, you can go ahead and work on the classwork for the rest of the time, which is changes of state homework. So in those boxes, you need to draw, I'm sorry, I should probably pull it up on my computer if I can find it. All right, you guys can just look at my background. In the boxes, you need to draw the atoms arrangement. So for example, melting is going from a solid to a liquid. So draw the solid arrangement molecules and then draw the liquid molecules with more energy. And then I want you to state, is it exothermic or endothermic? So do you need to add energy or remove energy to get to the liquid state? Okay, let me just see if I have this somewhere. All right, there we go. Okay, so the first part right here, write in melting. And then the energy change here, you write down endothermic or exothermic. And so for melting, we're going from a solid to a liquid over here. On this side, you want to write liquid. And you're adding energy. Energy is entering, so it is endothermic. So you'd write down endothermic here over on energy change. So go ahead and do that for the changes of state. Please exclude deposition and you should be good to go. Go ahead and get to work and good luck with everything. All right, see you Monday.